Good morning, ladies and gentlemen. My name is Wolfgang Miltner. I'm Managing Director of PolyIC, and I'm also a member of the board and Vice Chair of the OEA. And actually, my talk will be about printed electronics, organic and printed electronics. So you may think, oh, something completely different to that what you just heard, but that's not true. Actually, there is some overlaps. We just briefly talked about that, and there are some relations. And I'll try to give you in my talk an indication about what will be possible, but it's not just a future thing. Also, I will give you samples of what is already on the market. So it's not something where we talk about only future things. There is a lot of potential, but we talk about things which are happening right now, and we talk about the world of printing functions, not only printing some visual, some optical things, but even functional elements like complete electronics. And the title of the talk is From Lab to Production and Business. And that says, meanwhile, that we are moving out of the just R&D stuff. It's really going into production, and a lot of investment is happening right now, and it's going into business. Yeah. A brief definition about what are we talking about is really, it's a mix of very different technology. Of course, printing technology. It's the production method which will be used or is used here, and it's used because of printing as a very effective way of doing production. If you compare it, when we talk about semiconductor, you know it's a batch-oriented, high-precision, high-end process which costs a lot of money. Using a printing machine, especially roll-to-roll, could lead to really efficient methods of production. So that's one element of this technology. The other element is using new materials. So we see right now that there are materials, actually Nobel Prize was given for that. New materials come on the market, especially polymers, which can be used as an ink. So you can use that in a printing machine. So they enable this technology, but they are not yet completely ready. So they are still in development. The good thing on this is a lot of chemical companies develop that right now. So we see a technology push from the material side. And on the other hand, we have a really well-developed microelectronics world. But somehow it is due to the fact of another production and another material, it needs to be applied. It's not that we can use something out of the box from semiconductor companies, but we need to bring all these things together. That's on one hand a definition, but on the other hand also the explanation why this has taken quite a while to take off. Because actually all these people talk different languages. They don't understand each other. So you have to bring them together and to match them so that they understand what are the requirements and what are possible solutions. And one way to do that is bringing them into a network. And I will talk about this in one part of my talk. Another thing is, the question is, why should you do that? Where is the potential? What is the upside on this? What are the potential applications? And you see, it's quite a variety, and it's very, very different applications. We talk about really elements of passive integrated circuits, so things you can expect today from the semiconductor world, but they look different. They are very thin, they're maybe just on a film, and could be integrated. They are flexible, lightweight, and of course could be also very cost efficient. So that could be one thing. Printed transistor on a film, that is possible. On the other hand, you can use this for power supply. And you just talked about that. Printing a photovoltaic cell on film means that we have an enrollment for energy harvesting, and you get the energy and you could put it on the roof, but you can put it in a window, and people are doing that right now. This is already, in some buildings you find integrated photovoltaic cells based on these technologies. But you can also print sensors, and you can also print displays. So displays like this here, completely flexible, black and white, but also colored are possible, completely flexible, very thin, one way to do that. And you can use the same technology also to print lighting. That means you have not a light source like this point, it's really a film which has an area for enlightening buildings, but also other elements. So that applies to the technology of OLED, organic light emitting devices. And all this can be also integrated together. So you can print multifunctional systems. Some people call that smart objects. So combining all this into one element, very thin, maybe on a larger scale, but easy to integrate in packages, in several applications. So this is the world we're talking about. And will give you some ideas of what is possible of this world, which is, of course, more future. What is possible today out of this? I've given you first examples. Now I'll try to be more general, more generic on this, what will be possible. So we talk about very thin, very lightweight, very cost-efficient, flexible, and robust elements we can print. On the other hand, it enables low cost due to the fact of a very efficient production and new applications. One area we are talking about is really single-use electronics. So use it once and throw away. And you can throw it away because the materials which are used are safe for the environment. So also this is something we can take in account here. And people and companies in this area, one of their slogans is electronics everywhere. Bring electronics to areas where there is no. So you can enable an intelligent packaging. You can print into the package some logic where you can enhance customer feedback or customer interaction. And that is the new thing which will be enabled by this technology. I've talked about how can we make this happen. One thing is no single company can do that alone. You need collaboration. You have production which needs to be adapted. You have new materials. You have technology which needs to happen. And all the people need to come together and they need a common language. So we need a network. And one network which acts in this area is the OEA. The OEA is an international association which now over 220 companies and organizations which have joined. A lot of from Europe, but actually from Asia and US. Second largest group is from the US. So I think really showing that this is not just inside one country, it's really happening all over the world. And you see all the value chain is represented in this. And also that is what is needed to generate this new business. And so benefits are here, and I don't want to go in all the details because I would like to show you more examples out of that. But one thing they provide, and that is actually what you may find interesting, is all the companies collaborate to do a common roadmap, which then gives you an indication of what is the next step and what to do to make it happen. This is why they collaborate on this roadmap, and now the roadmap is already in its 5th release, so it's really a more mature type of roadmap showing that what's happening right now. I will try to focus now a little, or change the focus now a little bit to give you more concrete examples, because OEA is more the general overview. I'm also representing a company out of this. This is PolyIC. PolyIC calls itself the chip printers, and one of the slogans we have is smart and flexible printed solutions. We are part of a large group. This is the Kurz group, which does specialty films, but PolyIC was really founded for the vision of making printed electronics happening. And what we developed is really we use a roll-to-roll printing process, and I'll show you some of the details, which shows that just saying now I use a printing machine to do it is not the real truth. Actually, you have to adapt the processes. You have to really do do a lot of work to have experience how to use the printing process to handle it. So we've developed a process based on polyester film, which runs at a certain speed with certain parameters, but has really know-how to use different kind of materials in a certain speed and really develop products and functions as a result out of this production process. So this is more a generic way of describing what is the special thing on our printing process. We even had to develop a new proprietary printing process because some of the resolutions which are necessary to print active electronics are not possible with standard production process today. For instance, one example is 10 micrometers resolution, or even less than that, 5 micrometer resolution. And using that with materials like metals, that's something you cannot do with a standard printing process. So we have developed a process which makes that happen. To not go too deep into technology, this is the product spectrum which could be realized with this production capability, and some of these are developed further already at a pre-product stage. Some of them are real products, so we sell right now film on kilometer-long rolls for doing touch sensors. This I will go in more details, but there is a lot of other possibilities. So one thing is, of course, printing of Rfid, so making a product to be identified by printing and radio frequency identification tag. That will be possible based on this. But so I won't go in all the details, but just give you some concrete examples to give you an indication that this is not future. This is something which starts right now. First example is PolyLogo. PolyLogo is something which we call a product which is a radio-activated display. So in that sense, it's a display which is powered by an energy source which is not in the system. So it's a passive device, but it lights up or shows something when it's close to an energy source. How that could look like and how you can use it, you can see it here. We can use it for marketing stuff, you can use it for games or for tickets, for authentication. How it works, you see it on the small video. So actually, it could be a card. You could place it close to an energy source, and suddenly something pops up on the screen. And this is very low cost, actually, and it's an interactive element which could be put on packages or used as an authentication for tickets, for instance. Another thing, not an example of our company, but an example of how future packaging look like. The technology here in this case is really a lighting technology which is put on a cupboard or on a board, and the board, you see that when the power source is actually inside the package, and when you lift the package, the bottle starts to show. Yeah, you see the elements start to show some nice vision. Actually, this was done from Karl Knauer company for Bombay Sapphire, and is used in some special shops. Very high-end packaging stuff. I predict, and they produce actually a lot, and they have a lot of requests for doing more like this. But this shows how future packaging will look like. And this is due to the fact that new display elements are possible, just be printed. Another example of how to integrate light and wireless energy is this. So this is just a piece of film. You see, what could that do? And actually, if you look closer, you'll see that if it's coming close to this round element, it starts to light up. So actually, it's showing a hybrid integration of LED stuff, LED lighting, and power source by just printing a structure. So in that way, also showing hybrid integration of printing of semiconductor stuff and other materials to enable interaction and to enable lighting is something we see as a potential possibility of the technology. I have to say, beside the Bombay Sapphire, which is really in the market, the other things are prototypes. They show what will be possible, but they are ready to be scaled. So in that way, this is already something we can provide to the market, but it needs customer projects. Another example shown last year at the LuxPack is a way to make actually it's called active surface. So it shows that one part of a package is really changing, and of course it's used to attract customers, but shows also the capability of future flexible light elements. In this case it's battery powered, so there's a battery included. In the other cases we use wireless energy. So you see a lot of possibilities for new packaging, for interaction, but more future things. And so I want to give you another example what this technology can do, and this is something which is in the market. So that's not to be scaled, this is already scaled. Here we talk about transparent conductive films, so a film which is transparent but conductive in the other. So both are in that way possible, and that are used to replace today's ITO sensors. ITO is a special material used, for instance, in your smartphone to make touch sensors happen. But it's very expensive, it's hard to handle, the process does not allow for flexible solutions. So this is a solution, and you see some of the examples which with the advantages for really complete flexible products. And this is the layer setup, so I'll give you more details of how it's used. So it could be integrated in future mobile phones, especially not in the flat ones, but the curved ones or the flexible phones, which will come to the market soon. This is especially then having its advantages because it's itself just a film. Of course in tablets, but also in automotive, you will see a lot of touch functionality in the future, and especially there, they want to have curved surfaces. That should be nice looking, and they do not only want to replace touch screens, they want to have touch screens in your car, but also they want to replace the standard function keys. So the mechanical keys should be replaced by just a function for the surface. And that is possible based on this technology. And of course that applies also to consumer electronics, or even your washing machine in the future will have a touch-enabled surface. So a lot of opportunities for printing functional films which enable this technology. What we've developed is, on one hand, the sensor. We can print the sensor, but we even can integrate the sensor in plastic parts. So what we can use, for instance, is use a standard injection molding process to incorporate, on one hand, the injection mold, and as an in-mold label, the sensor, and everything is produced in one run. So a very cost-efficient integration method, which even makes the handling even better and efficient. On the other hand, so cost-efficient is one advantage. On the other hand, is the functional enable for curved surfaces that what is demanded by the industry. We've shown that on the K-Fair last year at Düsseldorf. We've shown this example of a dashboard for a nice car. Actually, we've done this because we cannot show the real project. The automotive companies do not allow us, so we made a fake one based on our ideas. But this is really a full enabled dashboard, center console, which can be used for switching on AC, so the air condition, but also using to do the navigation and so on. So full functional, but completely polymers, so printed solutions for functional elements shown ready to the market. So this is something which is already in the market. The first thing which I would say really is ready for a mass market, but still, as I explained to you, a lot more things to come in the area of printed electronics. I've explained to you that these are the areas which will be possible. And if you want to learn more about this, actually next week, same area, so at the ICM in Munich, we will have the LOPEC. The LOPEC is the Central International Fair for large area printed electronics. It's not as big as the FESPA right now, still growing, but last year we had 1,800, so roughly 2,000 attendees. We had about 120 companies which do show something. Right now, I already know the figures for the next week, so we will have an increase of another 20% showing their products, their technologies. So this is really a chance being here at the place, and we decided for Munich as a very nice place to do this show, for the exhibition and conference to have a state-of-the-art showcase. So LOPEC is the chance to see more, so not only PolyIC, but a lot more companies active in this field. So with that, I'd like to thank you for your attention. It's really, I try to cover a lot of things in a very short time, but of course I'm ready for any kind of questions to have thoughts about your ideas and possibilities. Thank you.